ever since my friend Angie and I entered high school and met Mr. Iqbala, we learned about the joy of board games. Being able to strategize and apply certain tactics to win is always a fun process, and Angie and I wanted to recreate this joy. So we decided to make a board game and apply the concepts we learned in our favorite class, math analysis.
Our board game would be simple. You are in your last year of high school and you are trying to make your dream a reality. In a series of 4 rounds, 3 breaks, and 1 final, you will have to take on specific extracurriculars and earn or maintain a certain amount of prestige points to ensure your dream is met. Players start off the game with C as their grade and 10 prestige points. They will either have to lose or gain more of those points depending on what their dream card asks for.
During a round, you will perform a task by grabbing a card from the top of the task card deck. You will have a minute to solve the math or trivia question. The person who doesn't finish before the minute ends gets marked late for that task and loses prestige points. During the break, you will be able to either join a club, join a sport, apply for a scholarship, or start a fight. Each action is a card that every player picks from the action card deck.
At the end of 4 rounds and 3 breaks, the players will take a final, which will involve each player to roll a 6-sided die and get to the required number on the final card in under a minute. Once complete, the players can choose to play another set of 4 rounds in a final, or end the game and rally up the prestige points and required cards individually. After everyone is done, each person announces what their dream job was and whether they achieved it or not.
While designing this board game, we had a few math-related questions we wanted to answer. How many dream job cards should we have if we want an equal probability of every subject, but also want each subject to pair up at least once on a card? What is a reasonable amount of non-subject cards, we'll call these joker cards, to add to the deck? What is the probability of getting a dream job card of any subject? And what is the probability of a joker card getting picked when the game has its maximum number of players, which is 5? Before we dive into the math though, allow me to explain a little further. In order to enhance a player's career exploration in the game, the Dream Career Cards and Club Cards are categorized into 8 subjects: math, science, art, history, language, literature, music, and physical education, or miscellaneous for club cards, as the sports cards technically count for PE. And to spice up the game, we added dream jobs that don't fall into any of the subjects, like Mafia Boss and Thief. These dream job cards require the players to perform tasks that disrupt the dreams of others.
Before we could answer our first question, we need to determine how many ways the subject's cards can be paired up. If there are 8 subjects and only 2 spots in a pair, then the equation would be 8 times 7 over 2 factorial, where 2 factorial takes out the same subject pairs. This means that math and art is the same as art and math. With this, our equation came out to be y is equal to 8x plus 28z plus b, where y represents the total amount of cards, 8 is the amount of subjects, x is the amount of cards within each subject, 28 is the total amount of double subject cards, z is the amount of each double subject card that we want, and b is the amount of joker cards. We decide that there will be 5 cards for singular subjects, 1 type for each double subject, and 6 joker cards in total. After plugging these into the equation, the number comes out to be 74. This means that if we want to ensure that every subject card has an equal probability of being chosen, despite the double subject cards, then we would have 74 dream job cards.
But why did we choose 6 joker cards? We got this number after doing a series of probability equations to see what would work best. Since we decided to have 5 single subject cards in each subject and only 1 double subject card, that made our equation y equals 68 plus b. We wanted b, the amount of joker cards, to have a low probability of being chosen, so it needed to be less than 10% or 0.1. After taking the probabilities of b if it equaled 1 to 10, we decided we would go with b equals 6, because the probability of that scenario came to 0.081 or 8.1%, which is under 0.1 but not too low.
Now that we have our numbers, what is the probability of getting a dream career card of a certain subject? The answer to this is actually quite simple. If we make S equal a subject, J stand for a joker, and SD refer to any pairing of a subject, then we make an equation that looks like this, where P means probability, 5 is the number of single subject dream cards within a subject, 7 is the number of ways a certain subject can be paired up with one another. For example, math can only be paired up with the other remaining subjects. The answer to this equation came out to be 0.62. So, the probability of getting a dream job in the field of math would be 16.2%.
Also within the lines of probability, we asked ourselves, what is the probability of getting a joker card when you have 5 players? To find this out, we used N choose R to see the probability of at least 1 joker card, then 2, and so forth until 5. Since the game is designed for a maximum of 5 players, not 6. We found that the probability would fall between 0.3033 and 0.00000372, which means that it is highly unlikely for all players to have a non-subject dream career.
With our board game, we were able to review a lot of combinatoric concepts and apply them to different aspects of our board game. Unfortunately, due to the lack of planning, we never got around to testing the game. However, me and Yerky have plans of fleshing out this game and hope to publish it in the near future.